affected by the autonomic response. And this should make sense. When you're in the fight or flight response, do you want more or less flow? Well, more flow, right? You're going to be doing something strenuous. You will want more air to exchange with. So you want to do what to your airway passages? You want to dilate them or constrict them? Dilate to reduce the resistance to create more flow. And then when you're resting, you don't need that much flow. And so you will want to constrict your airway passages, create the resistance to have a lower amount of flow. There is another form of resistance too, and it happens at your alveoli. And so the idea is actually these alveoli are like bubbles. If you look at an alveoli, it's basically just a sphere, with, a passageway kind of attached to it, and then there's a whole bunch of blood vessels kind of running around it. So in sense, an alveolus, is just a bubble. And so it turns out these bubbles have tension to them, right? And larger bubbles have less tension than smaller bubbles. I think, how many people have inflated an air balloon before, right? Hopefully everyone's done that. You notice it's really hard to start off, but then as you get further, as you put more and more into it, it actually gets easier, right? Well, that's this phenomenon, right? When that balloon is kind of small, it has a lot more tension. You got to put more pressure into it to kind of expand it. But as it becomes larger, it actually has less tension. And so that involves an equation called Laplace's law, saying the pressure of a bubble is 2 times its tension over the radius of that bubble. You don't need to know that equation. That's just the equation just to kind of show you that the relation if you want to kind of think about it quantitatively. But the idea is smaller bubbles have more tension. That's just kind of how the physics works of it. And so if your alveoli are small, that's a lot of tension. That's a lot of pressure. And if you want to breathe air into your alveoli, you have to overcome that tension, right? You have to overcome that pressure. That can be really difficult, especially if most of your volume of your lungs is alveoli. And so the idea is to reduce the tension of these bubbles, to reduce the pressure of these bubbles. Instead of just making them bigger, we're going to add something called surfactant. Surfactant basically intercalates with whatever is, making the bubble, whether it's water, membrane, mucus, whatever it is, and lowers the tension. It decreases the surface tension. So in this situation, if the pressure here was 3 and the pressure here was 6, if you add surfactant, then you can get the pressure to drop. And how much surfactant you add will determine how much you have a pressure drop. And so our alveoli have surfactant in them. And you can see the differences in the effect of surfactant. You can see the pressures and surfactant, the different surfactant here. So let's say you're in the pool, you're in the beach, you're in the ocean, whatever, and you see bubbles. Generally, they'd be very large bubbles, right? They don't last very long. They pop after a while, right? That shows that these bubbles have a low pressure. They're going to be large because of low pressure. But if you ever get soap, you see a whole bunch of tiny, tiny bubbles, and they last forever, right? If you ever try to wash bubbles down the sink, it's really hard because they just last so long. That's because soap is a surfactant. Your soap is a surfactant, and so when your soap mixes with water, it makes the pressure of much lower to make bubbles, basically. So it's much easier to make bubbles because the pressure is pretty low. Just an example of what surfactant does. But the punchline is your alveoli have surfactant that lowers the tension of your alveoli, and so that lowers the pressure to maintain that bubble, that alveolus, and so that helps overcome the pressure gradient, basically. Make sense? Okay. Cool. I'm going to go over this real quickly. You're going to go over this more in lab. So coming this Wednesday, Thursday, you'll be doing the spirometry experiments, and that's basically you measuring volumes of kind of the volumes of your breath. And so when we breathe normally, we call this our tidal volume. When you take normal breath in, normal breath out, the breaths you're not really thinking about. Or when you think about it, you're not really paying too much attention. These shallow breaths, the in and out, that volume of how much you inhale and how much you exhale, that difference is called the tidal volume. Now, if you decide to take a normal breath and then take in as much air as you possibly can, like this, then that difference here is called the inspiratory reserve volume. That's how much air you can potentially take up at most if you really wanted to. And then what's traditional in a spirometry experiment is after you take this big breath in, you exhale as much of it as you can out. That's what this big drop is. And whatever you exhale from there, that is called your vital capacity. And so you're going to do this experiment where you have the spirometer, it's like blowing into a tube. You take some couple of normal breaths in, take a big breath in, and then you exhale as hard as you can, and for as long as you can, and then you return to do a couple of normal breaths here. And then from the simple trace, you can make a whole bunch of different measurements. You can make measurements of vital capacity, you can make measurements of tidal volume, inspiratory reserve, things called expiratory reserve, all sorts of good measurements. And these are measurements that tell you a whole bunch of things about your lungs, about how well your lung muscles are doing, how compliant your elastic portions of your lungs are doing. This is actually used a lot at diagnostic tests, especially if you have asthma or if you have some kind of lung disease. They're going to make you do some kind of spirometry experiment. So we're going to have fun doing spirometry experiments in lab later this week. I just kind of want to go over it so you have a kind of a gist of it before you go into lab. Next week we'll pick up on alveolar ventilation. That's it.
I know, right?
Yeah.
So I checked on the proposal assignment, and it said that I didn't get any credit. I checked and I uploaded the PDFs, but I accidentally wrote the citations in all my work in the comment section.
Were you here for the beginning class?